Sorry, I've had to record this in two parts. My little daughter, my 3-year-old daughter, ran into the room. I'm working at home today, so I'll just carry on. I was in the middle of describing the website. So what you can see is, as I said before, the table shows the events, the chart shows the events, and each of the 96 events are listed in the table here. You can order this table by date, as it's ordered at the moment. And what you can see is, as I said before, the 7 largest events occurred in the most recent winter. You can order the table by return period, so you can see by far the biggest event, the 2 biggest events occurred in this last season as well. Now what you can do is, if you don't want all of the events, you can say, well, I'm just interested in the last decade, and the table will update accordingly. You can click on any event. So this is the biggest event. This had an overall return period of 843 years, the biggest event on record. And for each event, we've written a description of the storm, a description of the extremes, and whether coastal flooding occurred or not. So for example, in this event, 10,000 people were evacuated on the east coast. We've put a Google map that you can sort of zoom into, and the size of the circle gives you the indication of the return period. So at Immingham, it was 787 years. You can also look at the skew surge. So at Immingham, again, the skew surge was about 1.5 meters. We've got a table of all of the sea levels around the UK for that event. So again, you can click on time. It's quite interesting to look at the progression of the storm as well. We've put an option to contribute photos, so we're hoping when we launch this that people will upload photos for each event. You can download the data for each event, or all of the data. The other thing we've done is we've put the digitized storm tracks as well on here. I don't know why this is taking a second to load up. I'll stop that. We've done a nice little glossary, so we've got various terms with nice images as well. The other way, if we go back to the beginning, the other way you can go in is by location. And rather than looking at all of the data, you can click on a particular site. For example, let's click on Dover. And this now just lists the storms that have impacted Dover. So these are the events that have impacted Dover. And again, you can click on a particular event and it will take you to the event page. We've got information about the team, and we've also got various news articles as well. So we've done videos of what is a storm surge. We've looked at past events that aren't in the data record, for example, 1703. So as soon as I said before, we've got a papered review and about creating this data set and this website, and hopefully when that's accepted in the next couple of months, we'll formally launch this site. So this obviously has relevance to Floodmemory, but the actual website was paid through an impact. So that's the website there. I'll just show you the BODC, and for each site we've created a PDF here. So for each of the 99 events we've created a PDF, and the PDF contains the information on the website. So it contains a description of the storm, description of the sea levels, description of the coastal flooding. We've got the tables in there. We've got a nice figure showing the storm track and how that developed, and the pressure and wind. So you can see the wind into the North Sea here. We've got different times, so you can see how the storm developed. And then we've got these plots as well, which show the sort of spatial extent of the storm, and the size of the circles relates to the return period on this plot, the surge on that plot. With this particular event, we've actually written a lot more detail about the influence of the flooding, and we've got references and some of the data. Now I'll go through this quite quickly, but we've just finished a third paper, which we're hoping to submit this week, which Matt has led. And what we've done is we've assessed the 2013-14 season, but just at 2 coastal regions, in Suffolk and Sefton. So this applies to Sefton. And Matt's focused down on just a couple of sites, but done a really nice bit of work looking at the joint probability between sea level and waves. So we've got sea level on the x-axis, waves on the y, and again you can see the outlier of the 2013 event. So again, just to a nice study there, and we can send that paper to anyone who's interested shortly. Another thing that we've been working on, and we've got a first draft of a paper, which again we're hoping to submit probably in this month. But what Matt's done is Matt's done a very detailed, in fact the most detailed comparison of the 2013 and 1953 event. The problem with the 53 event is there's hardly any data, so he's actually gone back and scoured records, photos, things like that, and tried to sort of get an appreciation of what the event looked like. So if you look around the coast from Aberdeen down to Portsmouth, the red is the 2013, but Matt's been able to reproduce the 1953 using various sources of information. And you can see that certainly in the southern North Sea the 53 was higher, but most elsewhere the 2013 event was very big. And again, he's mapped the impacts of those events around the UK. So I'm actually quite excited about this paper. I think it will be a very interesting paper. The other thing, now this is, I've done all the work for this yet, but we haven't written it up. But for each of the 96 events, we've digitised the storm tracks, so shown here in the grey. Storms generate here and then obviously move towards the UK. And this just shows the pressure systems associated with those storms. Now the interesting thing is we can look at storms when the NAO is positive or the NAO is negative. Again, you can see many more storms quite closely bounded when the NAO is positive, North Atlantic Oscillation, much deeper pressures. The pressures are higher for when the NAO is negative, and the storms, there's less storms and they're more widely spread. The other thing we can do is look at sites. So this is Portsmouth, New Haven here, and we had 3 storms in the top 96 that produced events. And you can see the tracks of the storms and when there was a maximum storm surge. As we move around the coast into the Bristol Channel, we can see a slightly different tracks. Moving up the coast, you can see our storms tend to be further north. So as we go around the coast, this is a site in Scotland, and into the North Sea, you can see we have very distinct storms. So again, we've looked at the sort of tracks and the types of storms around the UK. And for each storm, as I've explained earlier, we've looked at the spatial footprint. So this is the very large storm surges all around the coast in the 2013 event, but the extreme sea levels were limited to two regions. So we've done all the work for it. I'm just in the process of writing this up as a paper, looking at the sort of characteristics of these 96 events, both in terms of the storm that generated them, but the spatial footprint. Now, most important for flood memory is the clustering. Now, with these 96 events, I've also just started to look at the sort of inter-event spacing. The event that's occurred most closely together was an event in February 1997. So on the 9th of February, we can see a storm being generated here and tracking over towards the UK, and that's actually the time of maximum storm surge. But we can see another event occurring very closely, and just 18 hours later, the first event has died out. The second big event moves in. These 2 storms both generated sea levels greater than 1 in 5 year around the coast. In fact, I think they were both in the top 10, quite significant events. But this event had by far the closest inter-event spacing, so it occurred about 18 hours apart. Now, I'm just working on another paper, which is a joint probability. We're actually doing a statistical analysis of the extreme sea levels and the inter-event spacing. So what this shows is, over that 100-year period, these are the 96 storms, and this is the number of days between each storm and the next nearest storm. Now what you can see is actually overall what this tells us is that clustering is quite rare. We've only got 1, 2, 3, 4, 5, 6, 7 events that occurred within 3 days of each other. As I said before, this 1997 event was by far the closest. We had 2 storms occurring 18 hours apart. So we have, if you look down on the bottom plot, this shows a histogram. We have 1 storm occurring within a day. We have 6 storms that occur within three days of each other. Now, interestingly, you then jump up, and after that, there's a gap between about 3 days and about 9 to 10 days. And the obvious reason for this is the spring neap tidal cycle. If you get a storm occurring on springs, another storm has to occur 3 days apart, in order to the subsequent storm cause flooding, because if a storm occurs any later than 3 days, then it's on the neap tides and you're not likely to flooding, and it will be another 10 days before you get up to something with flooding. So again, the spring neap tide cycle is very key in terms of inter-event spacing. Now just my final slide, and again this is very much work in progress, but I've taken this data set shown here and initially just independently fitted return period curves to that. So this is a Gumbel fit, I've got that on a log scale, and you can see the data fits a Gumbel distribution very well. And interestingly, the 1997 storm has a return period of about 100 years, as you'd expect. So that event, so to get an event occurring within 1 day of each other is about a 100-year return period. So this is very preliminary, and I was hoping to have got a bit further by now, but in this coming weeks, I'm going to just using copular functions do a joint probability between the sea level and the inter-event spacing. And I'm also having discussions with Jonathan Torn at Lancaster just to take this a bit further. So I've got lots of ideas, and hopefully some of this will be able to feed into Hashini's work package. So that's just a very quick summary. Hopefully I'm very happy to phone in if you've got any questions. So once again, I'm really sorry that I can't be